Students, honor students, this is lesson 8.2. A few of you were absent this day, so I'm sending a video recording. I'm going to be sending you the PDF as well. So this first page is review. You're going to need your calculator. Make sure it's in degree mode. Taking a look here, I'm going to do a couple examples. We're going to be doing something called inverse SOHCAHTOA. Inverse SOHCAHTOA. When we use inverse SOHCAHTOA, when we're looking for angles. So I gave you a handout earlier that has the different attacks you can use for a right triangle. Take a look at the inverse SOHCAHTOA side. I'm going to walk through these examples here. We use these when we're looking for angles. So if we're going to look for this angle, first we need to label. We're going to call that theta. Theta is the variable we use, or the Greek letter we use to represent angles. From that theta, we have the opposite side, and we have the hypo side. So we have an OH combo. And this time we're looking for angle theta. Because we have an OH combo, we're going to use sine because of so. So it's called inverse sine, parentheses, opposite over hypo equals angle theta. So you do inverse sine, and I'll show you how to do that on your calculator in just a moment. Opposite 23 over hypo, which is 39. Close the parentheses, and that's going to give us the angle theta. So most of you have the TI-84, so taking a look here, to get inverse sine on your calculator, sine -1, and it was 23 over 39. This is what you do. You start with hitting the second function button. Once you hit the second function button, you hit the sine, but it's going to give you inverse sine. Then go ahead and hit 23 divided by 39, and then the enter button. I'll show you what the answer should be here. Okay, so we're going to do, my calculator's backwards, so it's 23 divided by 39, second function, sine. You should be getting approximately 36.14 degrees. Let's do the next one. So from the angle theta, this is our opposite, this is our adjacent, and then this is our hypo. Notice you have all three. So you could do all three. I'm going to write down all three. You don't have to do all three. You just need to do one. Inverse sine. The opposite would be 75. The hypo would be 85. Would give you theta. Inverse cosine. The adjacent in this case is 40. and the hypo's 85. That would also get you the same theta, or you can use inverse tangent, opposite, which is 75, over adjacent, which is 40. All three of these would give you that single angle right there. And then to get this angle, you don't even need to use SOHCAHTOA. You just take it away from 180. Now, there's an important couple vocabulary words before we go on. That's called the angle of elevation and the angle of depression. The angle of elevation starts at a horizontal and goes up. The angle of depression is always going to start at a horizontal and goes down. So as you take a look at these next images on this page, you want to find the the angle of depression and elevation. I'm going to just pause 10 seconds each. You label on your paper, then I'll show you the answer. Find the angle of elevation and depression. For this one, it's right here. That is the angle of elevation. Horizontal going up, angle of depression, horizontal going down. Taking a look at this one, 10 seconds, label. Angle of elevation is horizontal going up. That's elevation right there. Angle of depression, horizontal going down. Right here, angle of elevation is you have to draw it in as horizontal going up. Angle of depression, horizontal and going down. Angle of elevation, horizontal going up. Elevation. This one you have to draw in the angle of depression, horizontal going down. It's very important you understand that sometimes you have to draw in the angle of depression. Angle of elevation, horizontal going up. Angle of depression, horizontal going down. There's actually two angles of elevation here. Horizontal going up, that's one. Horizontal going up, that's two. Then angle of depression, horizontal going down, that's one. Horizontal going down, that is two. What I recommend you do is pause this video and attempt these two problems completely on your own. Restart the video and then check. Pause. All right, welcome back. Let's see how you did. It said a Navy jet takes off at an average of 35 meters per second. After 1 minute, the jet is 650 meters in altitude, which is from jet to ocean surface. And it's 2.1 kilometers away from the flight deck. That's diagonal. The flight deck sits 20 meters above the water surface. We want to calculate the angle of elevation of takeoff. So you should have established your water line. That's the first thing. You have your flight deck. That flight deck is 20 feet above the water. The plane takes off like this. And after 1 minute, it is 2.1 kilometers away. Notice you have a discrepancy in units. So the 2.1 kilometers, we're going to translate to 2,100 meters. The altitude of the plane from the plane to the water surface was 650. But we want the angle of elevation, which is right here, horizontal going up. So there's our theta. This trick to this whole problem is when we have the hypo of this triangle. When we work with the opposite, you're not working with 650. It's 650 minus the 20, it's 630. So we have opposite and hypo. So you should have done inverse sine, opposite, 630, over the hypo, 2,100. Check your units, the fact that they are the same. And you should be getting approximately 17.46 degrees angle of elevation. Okay, this problem, it says that you were a SWAT team sniper in training, 6 stories tall, and each story is 10 feet high. Your tripod sitting on the ledge is 20 inches. You're aiming at a target on the ground. The angle of depression is 19 degrees. You're being asked how far is the target away from the base of the building. So you establish a ground line. We have a target that's on the ground. We have a building. Our ultimate goal is to find this distance from the building base to the target. Our building is 6 stories high, so it's 10 each, which means it's 60 feet. Then we have a tripod, which is what the sniper braces, and it is 20 inches. From here to here. Said the angle of depression from the gun, very important. You start at a horizontal going down, is 19 degrees. We took care of that. So there's your triangle. Your X, that is down here, which you're trying to find, can also go up here. Warning. This is the trick to the whole problem. Watch out. That distance right there is not 60 feet. Watch very carefully. From here to here is 60. But then this last little bit is 20 inches. So we're going to translate everything into inches. So 60 times 12 is 720 plus another 20. This whole thing here that you need to work with is 740 inches. Now, we have the opposite. We need the adjacent. You know you're using a side length, so this is traditional SOHCAHTOA. So it's tangent of theta over 1 equals our opposite over our adjacent. Tangent of theta, which is 19 degrees, over 1 equals our opposite, which is going to be 740 inches over our adjacent, which is x. Cross multiply. Tangent of 19 times x equals 740. And your x is going to end up being 740 divided by the tangent of 19. So 740 divided by 19 tan. And we get right here 2,149.11. But keep in mind that is inches. We're going to divide by 12. And we get 179.09 feet. Okay, students, the rest is yours to do on your own.